Hello, I'm GDI speaking. This will be the next part of the Win32 basic programming course. We are preparing all the time for learning the OpenGL 1.2 version. But first, instead of using the GLUT standing for Graphics Utility Toolkit Cross Library or GLF and W, we are using the native OS API. We are programming for Windows right now, so Win32 API, then the WGL standing for bridge between Windows API and OpenGL, necessary for creating OpenGL rendering contexts. Then we will talk some things about pixel format and structure named pixel format descriptor, and finally the full screen mode. In the last episode we finished our recording at description of a pick message function. In this video, the first thing that we will do, we will implement the message loop using this function and several other functions. So just to revise the information from the previous video, the most important function in implementation of the message loop in WinAPI is the pick message or the get messages. We will explain the difference between those two shortly. Remember that if a message is pending in case of the pick message function, the message will be removed from the queue and placed in this LP-MSG parameter. Specifying a null pointer for handle to a window parameter tells the function to check the current application's message queue, not the message queue for specific window specified, sorry for repeating myself, by the parameter age, W and D. Both filter parameters will be set to 0 for our purposes because we don't want to filter any messages. Instead we just want all and every message from Windows for our purposes. The last parameter, remove message, is assigned with the value PM remove, which tells the function to remove messages from the queue after they are passed. I've prepared the image about the message loop in action, how the message loop is designed. Let me show you it shortly. The message is the image is right there. We have the win main and the pick message with the typo, sorry for it, will fetch the message from the message queue. The messages comes from application, meaning window, or user input, window behavior or user input according to the window. Then we will use the function translate message that I will describe it shortly, and dispatch message, very important and easy to use function. Dispatch message, as the name suggests, just dispatches the message where? To the Windows procedure function pointer registered in the already registered window class. 1 minute. Server break. Then the dispatch message is receiving a pointer to a messages and dispatching a messages to already registered window procedure function, the WND proc, that will handle the message and return the return code to the Windows, signaling how the message was handled properly, improperly, there were some errors or no errors, or we invoked a default window procedure. And then the game logic is executed, or program logic. In our case, no game logic at this point, because now we are focused on just Win32 programming. Okay, so remember this image. It's very important how the message loop works internally. Okay, let's implement this in action. The translate message function, I forgot to describe it for you, is used to translate virtual key messages from the keyboard into the character messages. The character messages are posted to the calling thread's message queue to be read the next time the thread calls the pick message function. So if, for example, user is pressing the key, for example the P key on the keyboard, first message will be the VM and some virtual key press. Then the translate message will process and delete the virtual key press message from the queue and post a new message into the queue with the real character pressed, that meaning that the P key on the keyboard was pressed instead of the virtual key messages. This is the more advanced topic in the Windows programming domain, why the virtual keys exist and why they need to be translated and how the translation works under the hood. I will do it and explain it to you more deeply in the Windows Programming Advanced course rather than just the basics as in this video. Okay, so the translate messages is just like that. Just receiving a pointer to picked and received messages and return a bool that signals whether the translation was proper or improper. If the translate message will receive a pointer to a message that is not a virtual key press message, it will just do nothing and go further. The function logic will be skipped, so don't worry. We are safe to always call this message regardless of the type of our got and received message from the queue. The last function in the message loop is the dispatch message. This function, as I told you before, dispatches a message specified as its only parameter back to Windows, and Windows process the message again, and then Windows sends the message to applications window procedure. This is the message handler for the particular window. The dispatch message function prototype is pretty much the same, just the name is dispatch message instead of the translate message, and return type is long instead of bool, but doesn't matter for now what the long return value means in that case. We can safely ignore the return value. Okay, the message loop will terminate after a set condition has been reached. Typically the condition of the the end condition and stop condition of the message loop is equal to the end and stop condition of the whole Windows application, and typically this is the receipt of WM quit message, meaning application is quitting, window is closed, then destroyed, and now Windows wants to quit our application. WinMine terminates by returning the value of, this is something another, not just the return 0, but MSG of the last message, typically WM quit dot W param to Windows. This may sound hard to implement and more theoretically, but in practice is very easy and straightforward. Now we will implement, we have 3 points more in this video. Implement message loop using pick message pattern, then explain the difference between pick message and get message functions, very important. And then this printf stuff in case of Windows application. 1 second. Okay, sorry for that. I'm already back, and we want to implement the first point. The first point. So we are starting with WinMain. Then okay, some random message box was displayed. Then we are setting the window by creating the window class, accordingly registering the window class, creating the proper window with already window class registered. Of course, some proper and easy to understand straightforward error handling, show window, update window, that I explained in the previous video. WMD proc, the Windows procedure, is already explained, and in this video we will only dig much deeper inside this simple line, how the return code, the exit value, is passed from there up to this line return 0, and what does it mean, the msg dot w param, it should be returned from this function instead of just 0 or the return code, except from the easy and straightforward error handling stuff, such as the exit with the exit failure. This is the macro for just 1 or 0, but those are the typical seed and different stuff. I don't know Visual Studio very well. Please forgive me for that, okay? Okay. So first, let's define the exit condition. Exit condition. Let's ignore first of all this printf. This printf will be for later for the discussion. So bool done false. If application is done, we are not done. We are using the bool type from C++ rather than bool or GL bool or bool or bool from stdbool.h. I don't care about those various boolean types. So message loop until you receive a quit message. So while it's not done, we want pick message, and the message should be defined there, msg, just msg, as the local variable implemented on the stack, allocated on the stack, and then the null pointer in this, no filters, and remove messages as pm remove. Okay. If the pick message function returns true, that means we've got some message. At first, we wanna check in the simple way. MSG has the following fields. The message is the most important, that has the WM quit. That means done is true or Windows true, but I don't care. I prefer standardized way of using boolean values, to be honest. Else, we are going forward. We don't want to quit the application yet, so do game logic or GUI app logic stuff. No logic for now, so nothing for now. Then translate message with just a pointer to it. Then dispatch message to Windows, dispatch the message to Windows again. And the very important stuff is that, let's ignore this printf for now. Not return 0. Okay, this loop will exit if we will got the WM quit message. But why return 0? Maybe the code will be -1 or 1, or there was some error. I don't know. I don't care for now. So how and from where we should know about this? Instead of return 0, it's very important that you return msg.w_param. This is return termination code. Why it's like that? L param and W param are the extra data associated with the current message that sits inside the variable msg. So this msg right there is for sure WM quit, and if we generate the WM quit is generated right there. Post quit message is post to the queue. So insert the quit. This function inserts WM quit message to the event message loop of the application, and the parameter of it is very important. It's just the exit code. For example, 0 and this exit code is passed through the parameter wparam. So 0 gets inside wparam. If we would, this is the same as return 0 in this case, but it's more flexible and commercial level implementation, because for example, if we will proceed this one instead of just simple 0, because for example some error occurred. For example, we wanted to open a file in the init process, because WM close, WM destroy is the place for the init code, and the init was unsuccessful for some unpredictable and strange reason. We want to signal to the child process, or in general to the operating system, that something went wrong. And we wanna return 1 from the win main function. We can achieve this by passing the 1 as the parameter, and then this 1 will be passed in the w param here. So this will be the equivalent to the return 1 code, instead of the hard code that return 0, or some various and strange ways of if checking and using very bad global variables. I hate global variables, and everybody should accept some, for example, storing the game structure stuff as the single global variable, or some other exceptions, but this is rather an exception than a rule that the global variables are useful. That's an exception rather than typical rule. Okay, so we have this done. When this loop is entered, pick message checks to see whether a message is waiting in the message queue. If the message is found in the queue and it is not a quit message, then the application calls our application specific code. It's their application specific code. After that is complete, the message is translated, the virtual key to the character key press, blah blah blah. We will talk about this later on. But it's not very important. It's not that important in the game development domain and OpenGL course. And then the message is, after the translation, the message is dispatched back to the Windows before heading to the Windows procedure function for processing by the application. So in other words, before calling the WND proc, the Windows procedure that will handle many messages. Okay, as you can see, the message loop provides a rather simple and effective way of handling the large amount of messages that Windows might send to our application, because Windows might send hundreds and tons of messages to our application. In general, we are not interested in 90% of those messages. For example, WM virtual key press. This is the saying according to translate messages functions. Okay. Now a complete Windows application we want to implement after getting through two next points. The difference, this is very important. Get message does the same thing as the pick message, but the most important difference is, if there are no messages in the event queue, in the message queue, the get message function stalls and blocks in the proper term, blocks the whole application thread until the message shows up. This is proper behavior and very good behavior in the GUI apps, because the GUI apps are rarely real time and optimized for very efficient performance and edge cases, edge performance at the edge level. We are using the runtime function pick message because it lets the application continue if there are no messages in the queue. This is perfect for games because through this loop, through the message loop, we try here to implement the game loop. Of course, we need to add the million stuff right there. For example, implementing FPS, the frame per second counter, to invoke the game, processing game state, processing game rendering, just getting game input, reacting and changing state of the game, and then redrawing the scene, redrawing the window, every frame in our application. So getting and searching, checking for the messages through the windows, if there is an available message for us, must be, not should be, not might be, must be asynchronous rather than blocking and synchronous. We often use in this domain the words blocking and unblocking call. Pick message is the runtime function, is real-time function, and it's non-blocking function. We need no blocking function because then here in the place of this comment calculate some FPSs to make sure that we get a proper FPS counter, and we are calling the game logic related functions every frame, every frame, rather than blocking the main thread, because this loop works in the main thread of our application, and it can't be just blocked like that because there are not any messages from Windows and we are waiting for one. The Windows messages in implementing the game or the game engine doesn't matter which level of complication we want to implement, is not very important thing in case of the game logic. The calling game logic every frame and focusing of that is much more important in case of the game applications. Of course, in the Windows typical Windows programming course, we will focus on implementing the traditional GUI application, and more often we will use the get message function because it even allows us to get a proper behavior that no messages from Windows, no events, so nothing is happening. Application should just be in the idle state, because in the GUI application every message the bad word, sorry for that. In the GUI, traditional GUI Windows applications, the application is called to be driven by messages. Game is also driven by events, by messages, but not by the GUI, by the Windows messages. For example, WM Paint. This is the extra thing, not the main thing that we wanna use. The rendering thing, the entity systems, the networking code, those are the main things, and messages from those subsystems, our own implemented messages, not the Windows API messages. Okay, The third point, the printf stuff in case of Windows application. Let's assume we want to shortcut. We want to the handles are the pointers, but okay, we don't care. We want to just display the address of a pointer of our window, handle to our game window. This is the, of course, proper code, %p for the pointer address, no problem. But why this will not work? Because let's see, maybe errors or not? No errors. Wow. We have the window. The background is not repainted because we didn't specify the background brush. So Windows has no background brush to use while WM Paint message and begin and end paint functions pair to repaint our window. We will fix that shortly. However, we can use debugger to check to, for example, set breakpoint right there. I prefer to use GDB to be honest. I'm operating system person, not the C++ higher level, cout, cinin. I'm not fan of those solutions, but I will have to learn them too. Unfortunately, I would say sorry for that. But instead of using debugger, for example, WinGDB or OliGDB, the older one, and I think the better one, just my private opinion, and setting breakpoint right there to see and display the window handle, or using the GDB. Printf is not working because we don't have the console. We set here in the project properties linker system the Windows subsystem. So no console, the Windows, the WinMain, and Windows with the message loop in the heart of the application. Okay. So the typical approach that we use for displaying, storing, just gathering the logs, because those infos are called professionally the logs, are being displayed and stored using just the log connected functions from the Windows API. I will not dig into that now because it is not the topic of that video, but just to mention, the printfs or the object oriented with operator overloading couts will not work properly when using the Windows subsystem and WinMain. Because no console, no fun, no console displaying. Say bye bye to the terminal and to the console. The log functions and often your own implemented by you, your own logging library, for example, writing to a file or getting the logs in some other way, are much more efficient and useful in this case, because, for example, sometimes and pretty much always you wanna store the timestamp, log information, and level of log if there was a debugging log only, or error warning, critical error, why the application has crashed, maybe some exceptions, stack trace, if you know what I mean. Some of you probably know some of you probably don't know. It's perfectly okay. We are studying here much simpler concepts. Why we wanna store the logs? Because not just for fun, for displaying all the address of window handle, but for debugging purposes. If, for example, the client of our application will have some error, first of all, we wanna to see the client's logs, and that will tell us what has happened, why it's crashed, maybe wrong recompilation, maybe wrong DLLs, maybe some library wasn't found dynamically. It's okay, everything happens. Tons of bugs to be prepared with when releasing the commercial level application. That's pretty much okay. What's more? But as the tip, as an interesting fact, as the end of the to be finishing the topics of logging things. By the way, sorry for my tiredness. Being tiredness, it's before morning, and again I'm tired after being 9 hours in the aircrafts and in the airports. Sorry for my job. Soon, in about 1 or 2 years, I will resignate and quit it, probably switching to bigger Boeing 777 or another plans, doesn't matter, depending how my operating system talent and stuff will go on. Also depending on my family state, the wife and my own son state. Doesn't matter for now, seriously. Okay. In the most professional manner, when we have, for example, multiplayer games, and majority of them are network games, when the game has some problems or is crashing, the client of malicious and invalid, the game client having some errors, encountering some errors, should automatically send to our main game multiplayer server, and then we can spy everything ranging from time zone, of course, in the oh my god, I gotta sleep. Sorry for that, I'm really sleepy. Okay, now if we can see in the bits and pieces that make up a Windows application, we can actually build a complete one. I will build it from scratch because many comments right there, many explanation and quick and dirty codes right there. We will build one from scratch, and what will follow is the entire code listing of another type of Hello World Windows application, but this time we will do some extra things. Introduce the concept, very important concept of device context, that is beginning of GDI Windows module. setting the color of the text, and finally draw something inside the Windows window. Just the text, for example, hello GJM, but inside the window by the very famous text, a very famous function text out. That is very simple to use if you understood and handled everything properly before. The text shown inside the window will be blue and will be shown, of course, inside a white background window. By the way, the window will finally has implemented this thing. Handle to a background brush, and this will make the behavior not like this. I hate Windows. This should be redrawn, but no handle to a background brush. Windows doesn't know how to repaint our background because no background brush. Let me smoke the cigarettes. Remember that my lectures, I hate the words tutorials. My lectures are in the very lightweight fashion. I tend to teach people. I taught already many my friends and many people, and I use the lightweight and easygoing approach because I think this approach is the best to understand something. But I should be sorry, and I am already very sorry for being a little bit tired because of my aviation, pretty much the daily job with small pauses, and it's exhausting. It's really exhausting. If you're using two families, A320 and N330, two Airbuses families, short distances, many flights, long distances, less flights, but more exhausting, many teams, exchanging people. Doesn't matter, this is not aviation channel. Maybe I will create aviation channel and some tutorials about, for example, I don't know, how to start your aviation in January, even on simple glider, or how the Cessna 172 engine works, and why, for example, what does it mean to lean a fuel mixture or reach a fuel mixture. Doesn't matter for now, but remember, aerodynamics and thermodynamics are the two best areas of physics, at least for me. I fell in love with that. Even more with innovation, actually. Okay, that was a joke. Let me smoke a little bit and create a new project. but in the single file, okay? I don't want to implement an architecture in one go and simple demos of Win32 applications. Please don't include don't include Windows like this. This is an older header, and the oldest header that you can find is this one. I will discuss everything in full from zero to hero, from A to Z, Win32 programming course, I promise you. Okay, first the Windows procedure event handler, so result callback. Callback concept should be already familiar to you. Callback is something that is called back. The Windows is calling for us this function. We are not calling Windows procedure directly. Okay. Okay, message. Remember that this is only the message ID, not actual MSG, which is the fully message object. Okay, let me give 1 minute for smoking, please. Okay, I'm very fucking tired. Let's just finish this up in the proper way and let me sleep. It's sunrise right there in Darwin, Australia. Okay. So standard window procedure. New very important thing, handle to DC to the device context. I will comment only the new introduced things for that. We will print on char or even using C++, why not? Why? Then okay. Text. String long. We can display the ASCII text. Of course, there is text out A with the LPCSTR to the const char pointer string, and W with white string. We will use the Unicode string and standard switch because of the standard Windows procedure. Case create, there will be init code Now we need code, so return 0, case wm close. We are closing the window, post quit message with return code 0, 0, and most important case wm paint. Window needs repainting or updating. Window needs repainting, updating. For now, return 0. No default close or default close. And return div window proc with message param. We will implement everything boiler code for previous demos, previous projects, and then we will focus on the new code, talking about device context, text out functions, displaying something in the window. But first, just L just main instance. I will omit the sal.h code and function parameters annotation used by Microsoft in their API heavily, such as the underscore in, underscore out, in, opt, etc, that we were discussing in the previous videos. And LPS there. Oh my god. Then of course the handle to a window, then the message, not identifier but the structure of whole message. Bool is up, done. Then fill out the window class structure. Size of class X, without any too much comments, message boxes, repeating myself. Style will be the same. Okay. Name is correct. Name is correct. Oh my god. This is pretty much the same code that we were describing, introducing and talking about in the earlier episodes or earlier time in even this video. Okay, we loaded icon, now the cursor. Standard arrow cursor. Now, first new thing, background brush. Icon, the large icon, brush. get stock object from Windows, white brush, so white white background, but the cast is necessary right there. Like this. No menu again. Class name. Now the small icon. Icon small. What's the reason? Okay, Unicode thing. Done. Now registering. Just return 0, very easy. Error handling. Now creating real window. No extended style. My name, so window name. I'm just experimenting a little, not really. I could write a conversion operator from W string to this very strange written in Hungarian notation const wchar underscore t pointer, but this is not a place for it now. Typical basic Windows styles. And then we should create some structure, but this is just a one-time easy demo. Like that. Now what? No parent, no menu instance of our application and no extra parameters. Let's do very simple error handling without any message boxes. No necessary. And main loop message loop, of course, without the if is not necessary. Okay, let's specify the window, remove the message after retrieving it from the message queue. Of course, check if the message was wm quit. If then done is true, so quit the app, else here game logic, of course, and then translate message, and the most important dispatch message to the Windows procedure using the function pointer right there. After that, return I prefer to do explicit cast. Or not really. We should all add sol in notation to those parameters, but not necessary, and I'm not interested in that. And this is all about this message rather than WM Paint. So in WM Paint, the new code I will introduce right there. First, we need to get HDC. So, starting with the GDI, stands for Graphical Display Interface, is the WinAPI module responsible for drawing the widgets, text, widgets, buttons inside the windows, and it uses the device context. The device context we will discuss. One device context is for one window. Remember that we get the device context for each window by the function get device context, and pass there the handle to the window that we are interested in, device context for it. Now we can use this function that we will use more often, but let's do the much simpler approach. We were using the begin paint functions, yeah. So like this, but this just returns the device context that we were just not using and ignoring the return value of the begin paint function in earlier examples. Now we will use the device context, and paint will be just the same. And this will be the same as GL begin and GL end in OpenGL calls. So now set text color to blue, and every GDA call uses as the primary and pretty much always, but not always, often but not always, as the first parameter the handle to the device context that we want to use it. Based on the device context, the GDI function knows about which window we are talking about. And color ref, there is a macro that, for example, this will be the blue, and we will be talking much more about GDI if you are interested in this in the Win API course, the course dedicated to the Win API. But this is not it. We are just learning the basics of it to start with OpenGL and focusing on the graphics programming and other stuff. And last call text out again, GDI call, so first parameter the device context and the start position of text. Remember that X and Y are starting from the top level corner, not of the screen this time, but of the window that is connected with the device context passed in the first parameter. So in the middle of the window, for example, draw the text in the middle of the window, then the string, the white string, so text C here, and length of the string, text left, for example, of the type size T, because lengths are expressed, length sizes in the C++ are expressed in the size T that is mainly and very often just assigned data type. Okay, those are our two GDI calls. Try to run this application and discuss some of new things, but I think we already discussed mainly all of our new code. So what we have of errors? Of course I didn't remember always to change the subsystem if Windows API. We have the text and repainted. When resized, we have repainted. Repainted background, yes. We can always implement resizing of the text to be always in the window, but to do this we need to get, I didn't implement the close WM close case WM destroy. Okay, what's wrong right there? Done true. And quit. Just to be sure. I don't know, Visual Studio, how can I stop this up? Ooh. Where is that? Seriously, this is int size t. I don't care. It just demo. Please, please just stick with it. Close it. Okay, returning to the topic, if we want, after resizing the background window, to always have the text centered, we need to get new width and new height from the WM Paint message, and we will do this in the next episode. But for this episode, let's only review the code once again. The first thing you will notice is this macro Win32 len and min, and this keeps Visual C++ from linking extraneous modules that you will not need for your application. So don't make our executable result executable linked file unnecessary fat, and link only the modules that we will use. Okay, the Windows.h include will include all the Windows headers that we will need for this application. Remember that another header we might want to include is Windows X.h, which gives us some useful macros for Windows development, but let's wait for the next episodes, not in this one. Okay, in WND prog the Windows procedure, let's comment like that, Windows procedure. We have pretty much the same functionality as before, but with the few additions. Okay. First, we declare the handle to the device context. We are going to use the device context to use the output to the window. Of course, in the string, we can just declare the array of a string of or const pointer or const wchar underscore t pointer, but I prefer more modern approach. And what about device context? Device context is used as the data structure for output for graphics display output. In our case, the output is for graphics rendering in a window, in Win32 window, but we can have a device context for the printer, for the standard very ancient terminal, but mainly device context is used for describing a window. All output to the window goes through the graphics device context, and the context is mainly and pretty much always created by this call, but not in this example. In the future examples, we will always use getDC function. That's why in this example, the last time we used the return value of begin paint that returns handle to the device context of the not current, but passed as the first parameter window as well. Okay, we can use handle to device context to output to the window that is associated with this particular device context. So with that out of the way, we can see why we declared the HDC variable. It could be static because device context for the same window, and we are using always the same. The one single window will be always the same, so we could and should, for optimization purposes, use the static to not allocate HDC variable on the stack rather than in a static memory section. Okay. And this WM paint I've described recently. This block is run when the window needs updating or repainting from the move, resize, or other event that affects the window display and the way how our window is being displayed. Okay. Remember that the function begin paint returns the graphics device context for the HWND passed to it for the window. And we can then use this device context to set the text color with the set text color self-descriptive function and display the text with the function text out. For the time being, we will leave those two functions alone, but of course MSDN is there if we or you want to know more about those things. There are many more possibilities, even with only those two functions, the text out especially. And those possibilities and many more functions with GDI creating the menus and advanced Win API GUI application creating and handling will be discussed and taught to you in my future Windows programming Win32 API programming YouTube playlist or articles, because soon I plan to start writing some articles. Okay, next we have the standard Win main. This is the fairly straightforward because except those two lines, pretty much I have repeated everything from the previous demo, previous examples. What's more? Okay, I'm looking at my notes. Okay, be sure to note the order in which Windows setup task is accomplished. In fact, we can break it up into the list. As I said million times, but the last time I will repeat myself. Window class setup and refilling and filling the structure, then registration of window class, window creation, message loop with event handlers, and implementing proper window procedure, often called WND proc. And that's it for the episode. We have a fully working Windows application that is now ready to be modified to our liking and our purposes, or generalized into, for example, some configuration of class name doesn't matter that much, but for example those parameters, window name, XY, width and height of the window, at least initial size of our window. And in the next episode we can move to the next step. The next step will be incorporating OpenGL into our Windows application. And this will be the place when real fun will begin. Maybe not really real fun, but more of the fun. And let's prepare yourself to the term as WGL. WGL, called also as the wiggle, and the concept of rendering contexts. We will always have two contexts. The device context is associated with the GDI, and the rendering context that is associated with OpenGL and the wiggle. Wiggle is a bridge between, is the Windows library that acts as a bridge between Windows API and OpenGL, that allows us to create a rendering context from the device context for this device context for the particular window, often the single window, because the game is often the single window. So in the next episode, wiggle, then something about pixel formats, then how we can move from window mode to the full screen mode, because most of the games are working in full screen mode. And then we will start with the graphics theory, with the graphics programming and real OpenGL history, architecture, and what does it mean that OpenGL is the state machine, etc., etc. Okay, so thank you for watching GJM from the site. It was me, and wait for the next episode. Maybe from other topic, maybe we will continue this code. Let's see, it depends on me, my time, and what what type of topic for recording or writing an article will satisfy me. So see you soon, and goodbye.